In this lesson, we're going to look at percent composition. Before we get to that, though, I want to do a general example about percentage, and then that's going to lead us into our chemistry lesson here. So we've got an example where a bag contains 15 blue marbles, 30 red marbles, and 25 green marbles, and what I want to know is the percentage that each of these marbles is representing. So what percentage is blue, what percentage is red, what percentage is green. So if we're going to do green, to get its percentage, what we need to know is we need to know the number of green, we need to know the total number of marbles here, and then we need to multiply that by 100%. So we do have some of that, another 25 is available to us, so we're going to have to add up 25, 15, and 30. So let's go ahead and plug those numbers in. So we said that there were 25 green marbles, and if you total them all up, we have 70 in total. So we're going to multiply that by 100%. So on your calculator, go 25, divide by 70, hit the equal sign, and then multiply by 100%, and you should find you get about 35.7, and I've rounded to one decimal place for that. To determine our percentage of red, we actually have 30 red marbles. Our total is still 70, and once again we'll multiply by that 100%. Our percentage is a little bigger at 42.8%. To get our blue, we can continue with this method, or we can just say, well, we'll take our total, which was 100%, and we'll subtract off our two answers. So our two answers like that, and so our percentage of blue is 21.4. So you can do the final one like that, or you can just follow through with the previous format. So now that we know a little bit about percentage, let's apply this to some chemical compounds.
So why are we looking at that? Well, because percent composition essentially is along the same lines. We're going to look at the mass of each element in a compound, and then we're going to look at the mass of the formula. So let's calculate the percent composition of carbon dioxide. So step one is going to be, well, determine the molar mass of carbon dioxide. And it turns out to be just a little more than 44 grams per mole here. So if we want the percent of carbon, we're going to take the mass of carbon in this molecule, which is all right here. We've got one carbon, and it weighs 12. And we're going to divide by the molar mass of the whole compound. The grams per mole up top will cancel with the grams per mole. And of course, we need to multiply by 100% here. So we get 27.29% carbon. To repeat for the other element, oxygen, now keep in mind this time we have two oxygens, each weighing 16, so it weighs 32 grams per mole. Again, divide by the molar mass, multiply by the 100%, and you get 72.2% oxygen. If there was a third element, we would either repeat a third time, or perhaps even take 100% and subtract off our two answers. So in review, any of these questions, they all work the same. You need to first determine the molar mass, and then simply divide by the total mass of each element in that compound and multiply by 100%.